Hello guys, welcome to my channel. In this video, we'll be talking about the basic structure of a smart contract. We will also learn how a smart contract is compiled and talk about bytecode and ABI. This is an important topic because it will help us understand deploying and interacting with the smart contract in a much better way. And we'll also talk about Remix IDE because we'll be using it throughout the series. With that being said, let's begin. So Remix is a platform used to develop smart contracts. It doesn't have a complicated setup and you can directly start using their online IDE. They also provide a desktop IDE, an extension for VS Code and a CLI tool. But in this series, we'll be using their online IDE. Remix provides us with all these features: a Solidity compiler, a place to deploy and interact with our smart contracts, a file explorer, and all these other features. You can look at these features on their official website. Now let's jump to the IDE and see what it looks like. So when you open the IDE, Remix will automatically create a default workspace and it will have all these folders. Let's see what these folders have and what they mean. So the contracts folder has all the Solidity files. As you all can see, a Solidity files ends with the Sol extension. And then in the scripts folder, we have JavaScript code to deploy a smart contract using a specific JavaScript library. And then we have the tests folder where we write code to test our smart contract. Here we can search for our files present in the project. We can compile our smart contracts in this section. To compile a smart contract, you just have to select the file that you want to compile. Come here and then click the compile button. It will compile your smart contract and show you the results. And in this section, you can deploy a smart contract and start interacting with it. We'll be looking at it at the end of this video. For now, let's go through the smart contract and understand its structure. So every smart contract should start with these two lines. The first line, that is SPDX license identifier, specifies the license that a smart contract belongs to. Well, what is the purpose of this? So whenever we keep our smart contract open source, according to the open source guidelines, it has to belong to a specific license. In this case, it is GPL3. There are different types of licenses that our smart contract can belong to. If you want to learn more about it, then I will drop a link in the description below. Please check it out. So let's say you'll decide to keep your smart contract private for your personal project, then you can use the keyword unlicensed, which means that your smart contract does not belong to any license. And on the second line, we have Pragma Solidity. Pragma is a keyword that tells the Solidity compiler to use a specific version to compile our file. In this case, it is a version that is greater than equal to 0.7.0 and less than 0.9.0. Well, what is the main purpose of doing this? So the main purpose of doing this is to make sure that a smart contract does not break with a version that is not compatible with a smart contract. Let's talk more about this. Let's say that I remove this part. Then it means that Solidity compiler will use a version that is greater than equal to 0.7.0. And in the future, when a newer version of Solidity is released, for example 0.10.0, and the compiler uses that version to compile this file, and if that version has changes which could make our smart contract not work properly, then we want to make sure that we avoid such situations. So we must define a version range that will work properly with our smart contract. And moving forward, we have the definition of a smart contract. We define a smart contract using the keyword contract, followed by the name of the contract. And then we have the body of the smart contract, which contains variables and functions. Those who are familiar with object-oriented programming will see that the definition of a smart contract is very similar to the definition of a class. And then we have this comment which provides information about the smart contract. We will learn more about comments, functions, and variables in the upcoming videos. I hope we understood a few things about the basic structure of a smart contract. Now let's move on to learning about how a Solidity file is compiled and talk about bytecode and ABI. So you all can see from the diagram that Solidity file is compiled into two parts, that is bytecode and ABI. We'll start with talking about what bytecode is and what it does, and then move on to ABI. We'll finally talk about what is the purpose of why a Solidity file is converted into bytecode and ABI. Guys, this is an important topic. That is why I've created simple and easy to understand notes. I'll drop them in the description below. Please check them out and revise them later on so that you have a better understanding of this topic. We all know that computers don't understand the programs written in high-level languages, which means that it does not understand our smart contract written in Solidity. That is why the compiler converts the Solidity code into machine understandable language known as bytecode. Now that we know why the compiler converts our Solidity code into bytecode, let's talk more about bytecode so that we have a better understanding of it. So what is bytecode? Bytecode is a set of instructions in the form of machine language that is binary code, and it tells the computer to perform a set of operations. Every piece of information, that is every piece of instruction in bytecode, is known as opcode. The full form of opcode is operation code. It is also known as machine code or binary code. Opcode is 1 byte long. If this sounds confusing to you all, then I can explain this in a much simple way. Okay, so let's consider this sentence as a bytecode, right? And this sentence is a collection of words, and every word conveys some meaning to us. In the same way, bytecode is a collection of opcodes, and every opcode conveys some meaning to the computer, and it tells the computer to perform a specific action. I think that should make it clear, right? Okay, so let's talk about the role of bytecode. Yes, we know that bytecode provides set of instructions to a computer and tells it what to do, but it has one more task to achieve, and that is deploying a smart contract to the blockchain. So whenever we deploy a smart contract to the blockchain, we are actually deploying its bytecode and not the actual code, that is Solidity code. And how does a computer process a smart contract? Well, Solidity code is compiled and broken down into opcodes, and these opcodes tell a computer what to do. I think that is self-explanatory because we've already been through it. So to recap this entire complicated theory, bytecode is the representation of a smart contract, but at the binary level, which is used to deploy a smart contract to the blockchain. Now let's take a look at an example and see what bytecode looks like on Etherscan. So Etherscan is a website that provides information about all the things that are happening on the Ethereum blockchain, like the transactions, the pending transactions, the blocks that have been mined, all the accounts that exist on the Ethereum blockchain, and also the contracts. We want to take a look at this section because we want to look at the bytecode of a smart contract. So all these smart contracts are deployed on the Ethereum blockchain. You can pick any one of them. I'll pick this one for now. And then come to the contract section. And if you come down, you can look at the source code of this smart contract over here. And then if you come down, this is the ABI of the smart contract. We will talk about this in a bit. And this is the bytecode. This is not in a readable format. That is why I've switched it to Opcodes view. And this is what it will look like. So all these words, these are opcodes. We don't know what it means. That is why we will go to this website, which provides all the descriptions of the opcodes and what they mean. So if you want to look at the meaning of an opcode from here, then just copy that opcode. Come here and search for it. And then you'll get the description of what that opcode does. Get input data of current environment. So this is what the opcode tells the computer to do. And then we have all these series of opcodes which make the bytecode. So yeah guys, I hope we are clear with what bytecode means with this example. Now let's move on to ABI and talk about it. Before we talk about ABI, first let's understand what is an API. If we understand what an API does, then it will be easier for us to understand what an ABI does. Technically, API and ABI represent two different things, but they have a similar meaning. API, also known as Application Programming Interface, provides us a way to interact with a backend or a server-side application. So basically, it So using a URL, we can get data from a backend application or put data in the database or do different kinds of operations. In the same way, ABI, also known as Application Binary Interface, allows us to interact with the smart contract. It follows the JSON standard and consists of variables and methods that we define in a smart contract. And using that, we can interact with the smart contract. So how do we use an ABI to interact with the smart contract? ABI provides a standard schema. So any language with a Web3 library can use an ABI to interact with the smart contract. So at the moment, languages like Python, JavaScript, Go have their own libraries that allow us to interact with the smart contract. And I guess as time passes by, more languages will start adopting and coming up with libraries that will allow us to interact with a smart contract. And generally, we interact with the smart contract from a front-end application. So to recap all of this, ABI provides a standard interface for front-end applications to interact with the smart contract. So as we are done discussing about bytecode and ABI, I think we should know why Solidity code is converted into two parts. I mean, we should be clear about it before moving forward. So bytecode plays a role in deploying a smart contract to the blockchain, and ABI allows us to interact with the smart contract. I hope we are clear with that. Now let's move on to Remix IDE and learn how to deploy and interact with the smart contract. So we will compile this smart contract. You can find this smart contract in the contracts folder. So once you select that smart contract, go to the compile section and hit the compile button. Once the compilation is over, you can look at the section below. This gives us access to the ABI and bytecode of the smart contract. Let's talk about ABI because we were supposed to do it in the previous topic, but I wanted to do it for this smart contract as it's a basic smart contract. So this is the ABI. As we can see, it follows the JSON standard and it has two objects that gives us information about the functions that are present in this smart contract, that is store and retrieve. So it has objects that give us information about the function retrieve and store, and then we have this inputs property which tells us the arguments that this function accepts. It is empty right now because retrieve does not accept any argument, but the store function accepts one argument that is of type UN256 and its name is num. Right, so this is all about ABI for now. So this smart contract is a simple one. That is why we don't have a lot of information in this ABI. But as we keep learning new things in Solidity later on, we will learn new things about ABI. For now, let's move to this section and learn how to deploy a smart contract and start interacting with it. Before we deploy a smart contract, let's talk about environment and account. So environment is a local blockchain network started by Remix. It is mainly for testing purposes. So we can deploy our smart contract to this local blockchain network and interact with it without using a real blockchain network. So there are all these different blockchain networks. We don't have to know about all of them. Let's just select the first one. And whenever we are deploying a smart contract, we need an account. It's just like whenever we are signing up on a website, we use our email address, right? In the same way, to deploy a smart contract to a blockchain network, we need an account. So all these are test accounts with fake ethers. We can choose any one of them and then hit the deploy button. Once the contract is deployed, you can see this section here. This is where we will interact with the smart contract. This is the store function and this is the retrieve function. So what does store function do? It accepts a number and stores that number in the variable number, and the retrieve function returns this number to us, right? So let's test that out. We'll pass a number like 50 and then initiate this transaction. Once we do that, let's retrieve the number that is stored in this variable. As you can see here, it's 50. Let's use a different number. Yeah. So this is all about deploying and interacting a smart contract using the Remix IDE. I hope we are clear about compiling and deploying a smart contract. Now let's recap what we've learned in this video. So we understood the structure of a smart contract. We went through the compilation process of a smart contract and what bytecode and ABI does in the compilation process. And we finally deployed and interacted with a smart contract using the Remix IDE. Yeah guys, that's it for this video. I hope you all found this video helpful. Until the next video, have a great time and take care.